Hello guys, in the last video we managed to create a CDC system which was responsible to transfer data from a database as a source to destination using Kafka. But without having a proper monitoring system in place, it will end with nothing but a chaos in our production system. So in this video we are going to cover how we can implement a proper monitoring system on top of the data pipeline we created. So without any further ado, let's get into it. So just like always, everything starts with the GitHub repository I shared with you. This is a public GitHub repository for this channel, which is supposed to hold all the labs, configurations, applications, whatever that we create in this channel here. Every lab comes with a specific README file. You can simply go through it and replicate all the steps, so you will end up with having the exact same thing we created during the videos. So the first step is just like cloning this repository. I already cloned it, so the only thing that I'm gonna do is just like open it up. There is a README file here, as you can see. Just walking through it, we just prepare the whole setup. Just to save the time of the video, what I'm gonna do is just like going through this documentation step by step quickly, so we can have everything up and running, and then we will create a monitoring system on top of it. Let's see. So as already mentioned in the README file, we need to go to lab-kafka-connect. There is two specific directory. Let me show you the true structure of the directory, by the way. Maybe that's better. So we have application, under application Kafka, monitoring, Strimzi, and we have infrastructure. So basically just this is the convention of the whole videos in this channel. We use RGCD. So basically everything gonna be stored as a Git file in the Git repository. So to have the RGCD and all the infrastructure related part up and running, all the files are inside infrastructure directory. In this specific lab, as you can see, we have infrastructure directory. Under that, we have a Docker Compose file, which is responsible to bring up a Docker Compose. And that Docker Compose basically creates a Postgres instance in our local machine. This Postgres instance is going to be used in the pipeline we will create. So basically, the pipeline gonna stream the data stored in the Postgres and send it to the Kafka. We also have lab-kafka-connect.yam. So this one basically is a definition of the kind cluster. So to bring up everything as a Kubernetes cluster in our local machine, I use kind tool. And the definition of the cluster is already here. So I just need to use this file to bring up a Kubernetes cluster using kind tool. And from then on, I can just continue implementing RGCD and whatever other component that we need. You shall also see a directory named load generator, which is supposed to hold a simple Go application, which is responsible to bombard the database with fake data. As mentioned, it doesn't really matter which data is inside the database. What matters to us is just like having all the data streamed to the destination, in this case Kafka. And also we can see what exactly is happening in the system, including the speed of the read, including the throughput, including the memory utilization, the status of the connectors, and so on and so forth. We will discuss about it in detail, but just as a matter of illustrating what exactly is here, this is it. So infrastructure part is just like that. We shall see a directory named Kafka. So basically directory Kafka is responsible to hold all the requirements, all the files that is required to bring up a Kafka cluster, Kafka connector cluster, Kafka Connect cluster, excuse me, and Kafka connector. We also have another directory named monitoring. So basically, this part is the part that we are focused on today. Nothing specific. It will just bring up like a Prometheus stack in your local machine, your Kubernetes cluster. And we will see how exactly we can just leverage this Prometheus and configure it in a way that it can ingest all the metrics from Kafka and Kafka Connect cluster. The point is like, if you already have a Prometheus in your stack, if you already have Prometheus in production or whatever, you definitely don't need this part. You shall only configure your Prometheus to be able to fetch the metrics from Kafka exporters. We will get into it in a moment. And of course, we also have Strimzi. So this part, Strimzi operator, this part, Kafka, and this part bringing up the infrastructure is already covered in previous video as well. So I will just do it very quickly. So let's go to the infrastructure. We have it here. So create. So having our Kubernetes cluster up and running, we shall proceed to the next step. So the next step is just like by adding, installing the Argo CD using Helm. This is what I'm gonna do right now. Very good. What I'm gonna do is just like changing the name of this one to, let's say, infra. And then, yeah, what I'm gonna do is just like retrieving the password for the Argo CD, and then port forwarding in a way that I can connect to my Argo CD. So let me just split it, and then port forward Argo CD. Yeah, looks good. So let's see what we have here. If I go to my local machine, the same port that I just binded, Argo CD is up and running. So the user is always admin, but password is the one that we have from here. Amazing. The next step is definitely just like adding the repository to Argo CD. Connect, successful it was, and then go to create new application, Strimzi-operator project, the same project. You create the namespace for me, yeah, this one, and then let's say you can definitely go ahead with head because this branch is going to be merged soon, but yeah, for time being it's like this one. And then the paths. So as mentioned, as you can see here, everything is under lab-kafka connect and then applications. So here is the thing, lab-kafka connect /applications what's the name of the directory, Strimzi-operator. Cool. Strimzi-operator. You remember from first view, we definitely need to have Strimzi operator first because this is the operator that's responsible to bring up the Kafka Connect cluster and Kafka cluster itself for us. So here, and then the namespace going to be Argo CD. Looks good. What error do we have? Path doesn't exist. I have a typo. Lab-kafka connect application Strimzi. Yeah. Okay, cool. Let's have it synced. Amazing. And wait for operator itself to come healthy. Yeah, it's healthy. So the next step is just like by creating another application in Argo CD for Kafka. As mentioned, all these stages are already covered in previous videos, so I will just go through it very fast. I don't want to take time of this video, by the way. So I'm gonna be Kafka cluster, and here, and then create this one. Same source, of course. Let's say it's same branch, which was enable monitoring. I hope I won't go with any typos. Yeah, lab-kafka-connect /applications/Kafka. So let's go through it here, and then the namespace of the city, create it for me. So Kafka cluster sync. Yeah, looks like Kafka cluster is coming up. Give it a bit of time. Yeah, we can definitely also, I will change it to Kafka. We have it here. Yeah. As soon as Zookeeper is up and healthy, Kafka cluster shall be provisioned. You already see that the connectors are crashing. The main reason for that is just like Kafka itself is not up and running yet. So it would be better approach if I just use sync waves in Argo CD, but it's not the topic of this video, by the way. No worries. As soon as Kafka is up and running, then the Kafka Connect cluster will be also up and running. Yeah. Kafka first node is coming up. Of course, in this video, our Kafka is only coming with one node, but this is not the best practice for production. Of course, for production, you want to have it at least 3. But as mentioned, I mean, Kafka itself and its high availability is not the focus of this video, neither previous video. It's gonna be a separated video because it's gonna be a long story. But anyway, so we have Kafka as well up and running, and as you can see, the status of the Kafka Connect cluster is also coming up. Yeah, the first one is ready, the second, okay, we are good here. We are good here. So far we have Kafka cluster up and running. We just need 2 more things. First, we need to bring up Postgres, because this the Kafka connector that we created using CR is responsible to connect with that basically Postgres database. Although the Kafka Connect cluster is it's up and running, the point is like Kafka connector is not. So if I get like get Kafka connector, you shall see we have a Kafka connector defined or created, but it's not ready yet, right? And there is a reason for that. We don't have database up and running yet. So let's get into it. Going back to the infrastructure, I will just spread it like this, and then where am I basically? So docker dash docker compose of dash d. Okay, our database is up and running. Let me just check it. So in the servers, yeah, local one, and then yeah, the database is up and running. I have the table here created. I have table field with junk data in previous videos. So far so good. We have everything set, but still I don't think we have connector up and running. Let's see why. If I describe Kafka connector, type not ready, Ethereum, config validate, while validating, yeah, connection attempt fails. I see. So here is the point, guys. Please do not forget, I also mentioned it in the connector, PostgreSQL connector YAML file as well. This specific comment, you have to update this one with your local interface. If you are connecting with LAN, then it's gonna be like the LAN IP. If you are going to connect using Wi-Fi, it's gonna be your Wi-Fi IP. So what I'm gonna do right now, just like first get my address. So there you go, I have it. So edit Kafka connector, cool, and then the host, oops, the host. So this IP is wrong, -26. So if I give it a bit of time, let's see. Looks like it got ready. Yeah, it got ready. Very good. So at this moment, we have the full infrastructure we require to create a monitoring system on top of it, up and running. Now it's time to focus on the monitoring part and see how exactly it works. So as you know, Kafka and Kafka Connect both are Java applications. So basically they export metrics in Java native ways like pins and JMX metrics and so on and so forth. But it's also possible to fetch all those metrics, or let's say it would be better to say it's possible to export all those metrics to Prometheus format, so Prometheus as well is able to comprehend it. So here is the thing, we gonna use Prometheus, Grafana, and the integration of these two to have the monitoring system. Also, we leverage the capability of Kafka and Strimzi by default to export JMX metrics. So basically, all those metrics gonna be transformed and exposed in a way that Prometheus can also understand it. So having all this in place, the only thing remains is just like configuring Prometheus in a way that it can just fetch those metrics. And we shall see it in details how we can do it. Let's see. Just checking out let me just increase the font size a bit, maybe it will be better. So if we go to the monitoring, we have an Argo CD application for bringing up a Prometheus stack. As mentioned, this is the lab. So if I want to go to production, I would probably not use it, honestly speaking. Although using operators is a great idea in general, but the point is like, sometimes this particular operator is not very reliable. I don't know why, but this is my personal experience, maybe lack of knowledge, I don't know. But the point is like, I saw some crashes and some misbehaviors when using this specific operator. But anyway, in this lab, we will just create a Argo CD application which is responsible to bring up a Prometheus stack. As soon as you have Prometheus stack up and running, you can use this Prometheus stack to, basically it will just create a Prometheus operator first, right? Using Prometheus operator, you can create as many as Prometheus instances you want, and you can configure it. And not only just configure it in a simple way, not a traditional way, I would say, you can also configure it in even more dynamic way, which is like creating resources like pod monitor. We will just check it together, but just to mention, leveraging this resource just makes your life way easier. And the reason is just like, I personally never felt that much comfortable with just configuring the Prometheus because of the syntax and scraping and so on and so forth. I mean, even if it's not working, just debugging it is not that much easy. So we have operator to create this resource, and this resource will dynamically just update the scrape configuration of the Prometheus, which is amazing. So you will be sure that you won't have any kind of typo. I mean, I'm a typo person, so you won't have any kind of typo, you won't have any kind of misconfiguration, you won't miss anything basically, and so on and so forth. Let's see it together. In the components directory, we have a resource, namely Kafka Pod Monitor. So basically, this resource will bring a set of rules for Prometheus, understandable for Prometheus, and basically creates, let's say, a scrape configuration for Prometheus. So whatever you define here, it will be used for Prometheus. And when it comes to pod monitor specifically, that means that this resource is about to select particular pods with a specific particular specifications, whatever it is. It can be the label, it can be app name, I mean whatever, but you define which pods should we select. And this resource is responsible to just discover the whole cluster, find the target pods, add them to the scrape configuration of Prometheus. So yeah, I mean the name, nothing important. The selector part, the most important part, as you can see. We can see that we use the selector and then match expression with the key strimzi.io/kind. What is this? So there are several ways that you can just target the pods, but the point is like, all the pods that are being created using Strimzi operator is coming with this label, strimzi.io.kind. And then this is going to be key, and it's going to have some values. Depending on which component it is, it will just hold a value. If it's a Kafka, the value is going to be Kafka. If it's a Kafka Connect, it's going to be Kafka Connect, and so on and so forth. So this is the exact thing that you also see here. I mentioned that it should be Strimzi.io as a key, /kind as a key, and then values should be one of these: Kafka, Kafka Connect, Kafka Mirror Maker, and Mirror Maker 2. I mean, this one is probably by mistake, but anyway. So this is it, and then in the next step, I say that, hey, you just consider the namespace with the name Kafka, right? So here is the thing: we just instructed this resource to monitor, to attach, let's say, to consider all the pods that are currently inside Kafka namespace, and also the value for the Strimzi.io/kind is equal to Kafka, Kafka Connect, or Kafka Connect, Kafka Mirror Maker. So this is it, and the next step is just like pod metrics endpoints. It means how exactly the scraping should happen. We already defined that it should be on the /metrics endpoint and with the port namely TCP-Prometheus, right? So here is the point: as soon as you enable the monitoring for Kafka, I mean the Kafka and Kafka Connect that is being deployed by Strimzi, the point is like there's gonna be a port named TCP-Prometheus, so it's just like a port with a specific name, and we already mentioned that, hey, you should just go in this port, connect to this port, and just call endpoint/metrics. The rest is just like the Prometheus structure. We just have relabeling roles here, just like check all the labels for starting with Strimzi.io and then send them to the attach it to the Prometheus metric and so on and so forth. This is for understanding in Prometheus what metrics is what and where exactly it's coming from. This is it. This is about this part, and the point is like just having this file in place is enough. I mean, if we see that it's not enough, we can definitely just modify it, go back here and come back here and start adding the things that we need. But it makes it readable enough in Prometheus, so we can simply just use the metrics in Grafana. And yeah, other than that, the values file for the Prometheus stack or Prometheus operator, it's just like this, a simple one. I just have Grafana enabled, which means, hey, I want the Grafana to be deployed. Prometheus enabled, of course, I need Prometheus. In the configuration of Prometheus, I already mentioned that you already have a pod monitor selector because we created the pod monitor. Let me just, yeah. So the pod monitor is here, right? So the name is like Kafka resource metrics, and here I also mentioned that just Prometheus should use the pod monitor with the name Kafka resource metrics, the same name defined here. And then Prometheus operator, I need it definitely. Alert manager and so on and so forth, I don't need it, so I just set them as false. So this is about the Prometheus part. But even if you have it deployed, it cannot receive a single metric from Kafka. The reason is just like by default, the JMX exporter is disabled in Kafka. So if you are going with like standalone Kafka services or not like a Kafka that is being deployed by Strimzi, you definitely have to install JMX exporter for Kafka. That's the way that Prometheus can actually just get those metrics. If you are going with a Strimzi, it is as simple as just, let's see together. It is as simple as just going to the definition of Kafka and Kafka Connect. So let's start by Kafka. In Kafka, in the metrics config, we have type JMX Prometheus exporter, which basically indicates that, hey, I want JMX Prometheus exporter being installed with this Kafka instances. And I already mentioned that you should read the configuration for transforming JMX metrics to Prometheus from a config map with the name Kafka metrics, and inside that I have more than one keys and values, so you need to rely on the key kafka metrics-config.yam. The same goes for zookeeper as well, this part, but this time the key is zookeeper metrics.yam. And then you also have to create the config map with the name of Kafka metrics, and all those transformation rules, how exactly you should translate JMX metrics to Prometheus metrics, goes here. So this is not like I just created all of them, because this is not the reason that we are using Kubernetes operator, Strimzi operator, or any operator in general. All of these configurations are already mentioned and defined in the Strimzi documentation. So just like a bare copy and paste from the configuration they provide us with. So this is for Kafka. If you want to see it, let's see it together. Strimzi, Kafka metrics. So yeah, here is the thing, and as you can see, this is under the example and the metrics and the Kafka metrics, and all of them is already defined here. So it's not like a full discovery part, it's just like copy and paste from the effort that Strimzi team has already made. But in general, let's go back to the Connect. The same thing we have for the Kafka Connect as well. We defined JMX network export, we enabled it, and we are relying on this config map, and then all the rules are defined here. And again, this is the rules that are already created by Strimzi. If there is particular metric that you know that it's already exposed by JMX metrics, but you don't have it in the Prometheus, so the only thing that you have to do is just like finding that metric and create your own specific rule for that, or append it to the current rules. And therefore it can basically also be exposed to Prometheus, and you can see it in Prometheus in your graphs. So as the Kafka cluster that we currently deployed is coming with this part, we can basically go with installing the monitoring stack. Let's go back to the Argo CD. I would create another application, namely monitoring-Kafka, maybe, something like that. I want to create the namespace, same repository, enable, and then lab-kafka-connect /applications/monitoring. Here I have this one, or let's see, the fast. One note about this Prometheus stack specifically is that I'm in a hurry and I don't want to wait for fail. The thing going to be fail, and the reason is just like some of the CRs are too big for Argo CD to be parsed in Argo CD itself. So in that case, we have to use sync and apply server-side apply. So this is the way that we go through it. Cool, we already have Prometheus operator. Looks like it's up and running. I see bunch of errors. It might mean something, but let's see. The Grafana is up and running with no problem. That's good. And I don't see the Prometheus itself coming up. So the only reason that I can conceive of is just like the operator is coming with an issue, as mentioned. It's not a perfect one, I would say, or maybe it's not compatible with the kind cluster, I don't know. But let's see. So Kubernetes, Prometheus it was, yeah. Oh, what? Okay, get PO. Okay, what I'm gonna do is just like rollout restart operator, because I want to get rid of that specific error I had and make sure the new coming Prometheus. Oh wait, as soon as we got it restart, the Prometheus has been created. That's a good sign. Pod initializing. Yeah, it's running. Amazing. Very good. So if I want to connect to the Grafana, let's see what I can do. This is for Kafka. Let's bring another one for monitoring one, and then can you get secret this one dash yam. I need to come up with the initial password of Grafana because I want to connect to it. Echo this one base64-d. Cool. Yeah, such a cool password it is. Okay, amazing. So what I gonna do next is just like by port forwarding. Forward Prometheus Grafana looks good. And let me copy this one. If I go to okay, admin it is, and then this one looks good. The last and final step that I need is just like by having the required dashboard installed in Grafana, so I can start monitoring the Prometheus metrics. What I'm gonna do is just like going back here, let's say Strimzi Kafka dashboards. This is Grafana dashboards for Kafka itself. I will just copy it. Very good. Going back to Grafana, let's import it. Strimzi looks good. It detected the Kafka cluster. Yeah, the metrics are coming. I also need to do the exact same thing for let's say Kafka Connect cluster. Kafka Connect cluster. Kafka Connect, yeah, looks good. So going back here in the dashboard, import. Let's see. Yeah, cool. So we basically have the monitoring stack up and running right now. We shall see what exactly is happening in the Kafka, what exactly is happening in the Kafka cluster, and so on and so forth. In the last part of the video, I also like to add important metrics that you need to know when you are working with the CDC system, because sometimes it comes really annoying, most specifically because if you want to talk about Postgres specifically, it uses val files as write-ahead logs to replicate all the changes happening in the database, send it to the Kafka, and from Kafka to whatever place you want to send it. But the point is, like, if you don't have a proper monitoring on top of it, sometimes this process would just come with huge val size in Postgres database. You might think it's not that much important because at the end of the day, it will be melted down and absorbed by the Kafka connector, but the point is like, this is not true. Because in production environment, when you have big database with lots of interactions and just actions in different tables and so on and so forth, it can very quickly lead to a chaos. It can very quickly lead to the situation of going out of this, which makes the master node read-only, and that basically means that your application is going out of service. That it is. And it's not that much easy to just increase the size and so on and so forth. If you are using the third-party service providers for databases, it definitely takes time to change the size of the disk and just change the plan and so on and so forth. If you are coming with like self-hosted, then it comes with other challenges, but the point is like, you should definitely avoid it. To avoid this situation, you must monitor what is this, what is the speed of read, what is the queue size, because all the connectors are coming with a specific queue size. Queue will form whenever they just get one change from database, but Kafka is so busy, so they cannot deliver it to Kafka for any reason. Or sometimes it needs to wait for an ACK from Kafka side. So although the message is already inserted to Kafka, but Kafka is so busy, so it cannot send ACK back in time. And that's the reason that connector would hold off until it gets the ACK and then send the next message and then send the next message and so on and so forth. So any of these components can be turned to a bottleneck. And to check all of those, you basically need to see how many partitions do you have. Are you reaching the maximum number of partitions or not? I mean, fortunately in Kafka side, they decided to not continue with the Zookeeper and they are currently leveraging the KRAF mode. So basically that limitation with the number of the partition is going to be gone. But the point is, like, prior to that, you had the limitation of, if I'm not mistaken, 4,000 partition per broker. So if you go above these partitions, Kafka goes unstable. And that limitation basically comes from the Zookeeper itself, which is resolved right now. What I want to say is just like, you definitely need to make sure that the connector is working. If it's not working, it will lead to a problem for the database. You should definitely have to have a monitoring over the speed of the ingestion, how many messages per second, how many bytes per second, how many megabytes per second are being used. You should definitely check the status of the Kafka cluster. If you are going with the Zookeeper, the status and health of Zookeeper. If you are going with the Kafka itself, the status of the Kafka. You should definitely be aware about the status of the Kafka Connect cluster and the distribution of tasks. So if you want to check it here, for example, we have only one task, but as you can see, our Kafka Connect cluster is coming with 3 nodes. And our task is already placed in one node, and we don't have more than one task. It's a very simple scenario. But the real world scenario is not like that. So basically you shall have hundreds of connectors probably, and then the distribution of that definitely matters, because if all of them are accumulated in one specific node, it will just be an overhead for the Kafka Connect. Of course, Kafka Connect is responsible to distribute it in a way that it's not facing that situation, but anyhow, it's good for you to be under control of this. Assign tasks, and also here is another important graph, which is like connector task state. You might face with some situation that one or many connectors goes offline silently. If you don't have a proper monitoring on that, it would definitely end up with a chaos, with a catastrophe for the database, because as mentioned, it just deals with the master node all the time. So this is the other part, and also you can see the status of the Kafka connector with the name and the class that Kafka connector is using here. So you can definitely define metrics based on these variables here. If it's not running, if number of failed goes above 0, if number of powers goes above 0, and so on and so forth, you can simply see it here. You should definitely also check the JVM CPU utilization and memory utilization, I mean heap stack utilization as well, because this is the part that a Kafka application would go out of memory. This is about this part, and the other part for the Kafka, let's see it. So definitely, I mean, very simple cluster, one broker. So, but in general, you should see the number of the brokers, the healthiness of the brokers, of course, the memory utilization. In the production environment, you would definitely set a limit, or it will consume all the memory during the time, literally all the memory of your system. This is how it works. So memory, so Kafka could come really memory hungry. So you need to have a memory limit defined for it, for the JVM, and you should all the time just monitor the memory usage of it. CPU utilization. Here is the total incoming bytes. Of course, you need it because you want to see how fast Kafka is right now, and if you have an average for it after a while, and then you notice that hey, the speed is dropped, you have to figure it out, because that's an indication of an issue in your system. And also the same way you shall have like JVM metrics, but not here, interesting. But you can definitely add it because this is something that it's being exposed as well. And yeah, just to see if it's worked right now or not, it's gonna be as simple as just like let me just quickly go to DevOps lab Kafka Connect less than infra load generator, right? So I would go to load generator and I would go run, what do we have here, load test/go. Export go bin. So again, cool. As you can see, it's just sending lots of bunch data, junk data to the database. I see some activities here, but the point is, like, what I would like to see is I would be able to also see it in the metrics here. So for example, incoming byte rate, or if I go back to the Kafka Connect, I shall see a jump here, not as a matter of bytes, but as a matter of megabytes or kilobytes at least. Depends on how fast data are being inserted to the database. But let's see. So as you can see, instead of bytes, it just increased to like 400 kilobytes, and I think that's the most I can get from my local machine. Looks like it, but you shall see these metrics are just now talking to us, right? So I mean, CPU utilization would also increase bit by bit, probably, I don't know. But yeah, if I go back to the dashboards for the Kafka Connect as well, I shall see the same thing here, hopefully. Yeah, so it just jumped to 150 kilobytes. I think it comes with a specific delay because, yeah, it's an average of some rate of 5 minutes. That's the reason. But anyway, so you see whatever is happening with the Kafka cluster and Kafka Connect cluster. You now are able to monitor it and see it, and you should definitely just define like metrics on top of it. I hope you found this video as like a clue for the rest of the journey. Everything was so simple, it's just like for explanation. It's not a real production-wide, I would say, cluster and setup, of course. But the point, like, I believe it just provides you with enough of information to just continue the journey. Now know how exactly you're supposed to create a monitoring stack, about the resource, about the pod monitors, about operator, Prometheus operator, about Strimzi operator, enabling JMX metrics, JMX Prometheus exporter, defining rules for JMX Prometheus exporter, and so on and so forth. So basically, all the materials that you would require to just create a monitoring system is already provided. I wish you use it in the future. And if you liked it, please give it a like and do subscribe. See you in another video. Bye bye.